Hey there, welcome back to another video, and in this video we're going to discuss about introduction to switching. So we'll look at how switch actually forwards the traffic and what all the decisions that are available when switch kind of decides whether to forward the traffic or to filter the traffic. And before moving over to switch, you also need to know that before switch we had another device that was working in the place of switch and which was called as hub, correct? And there were certain drawbacks that were present when we used to have hubs in our network. So consider if you have A, B, C and D as the devices that are connected with hub, and be it hub, be it switch, or be it some other device called bridge that was kind of the original replacement of hub, and then switches came into play as like majorly when the game became more serious about building the complex networks in the world together. So if A in this scenario wants to send the data to D, then hub couldn't do that because that transmission would be called as unicast forwarding. And if we talk about the type of communication that you can have, so you have unicast, you have multicast, and you have broadcast. So hub only had the ability to do broadcasting. Okay, it couldn't do unicast and it couldn't do multicast. And then switch came up, and switch could do all these transactions, or switch could do all these network communications altogether. The problem with hub was it didn't maintain anything that was something like MAC table. So hub didn't have any brains to maintain such information called MAC address table in its memory. Okay, and because whenever the packet used to come from the device, hub couldn't see that what's coming into the hub and where it needs to go, because whenever we talk about the TCP/IP models, then at data link layer it collects information in the Ethernet header about source MAC address and destination MAC address. These two are quite an important fields that are filled with the information that is necessary at data link layer. Okay, and whenever the frame is being you could say crafted, this information couldn't be processed by hub because it doesn't have something called MAC address table to store the information in it. And that's why hub couldn't decide whether to forward the traffic on this port, let's call it as 0/1, 0/2, 0/3 and 0/4. So hub couldn't decide on which port the data needs to go, and that's why as a matter of fact, hub just used to forward the traffic on all the ports except the port that the data was being received on. So that was one of the major issue that hub had, and switch was kind of a fix to the issue that was present into the hub. So switch has the ability to do unicast and multicast and broadcast because it maintains something called MAC address table, and the content of the MAC address table is you can say the MAC address itself and the port with which the device that carries the MAC address is connected to. So if you have 4 devices in this topology which has certain MAC addresses and the port number that it's connected with, then switch will maintain the details about it in its MAC address table. So it would build up a MAC table kind of like 0 to 00. The PC that has this MAC address is connected to 0/1, and then certain other MAC address is connected to 0/2, and then 0/3 and 0/4. So that's exactly how MAC address table is created, and then whenever the data gets transmitted into the switch, then switch looks into the MAC table and then it sees that what's the source MAC address and what's the destination MAC address. Okay, and based on the information that is being provided into the Ethernet header, it looks into the MAC address table and checks that okay, the destination MAC address is this, and it looks that okay, that particular MAC address is connected to port number 2. So it will just forward the data out on port number 0/2. That's exactly how it does unicast and also the multicast. Okay. And if the MAC address that is mentioned over there, so as you all know, MAC address is basically a 48-bit hexadecimal address. It is written into three, you could say, sections. So this, so you have first section, second section and third section, and each one carries 16, 16 and 16 bits in it. So if you have, so the last usable MAC address is dedicated for the broadcasts. So you can have all Fs. If you have a destination MAC address as this means that it's nothing but a broadcast message. Okay. So as I told you that switch can do unicast, multicast and broadcast. So that's exactly how switch's logic is kind of considered while forwarding the data, and it does the forwarding of non-unicast frames. Now as we discussed that whenever the MAC address of source and the MAC address of destination is mentioned, or is, you could say, stored into the MAC table, then those frames are called as non-unicast frames, which means the addresses of this frame of the data that is contained into the Ethernet header is known by the switch in its MAC address table, and that's why it will be called as non-unicast frames. And if the switch is able to forward the data, then that's basically nothing but the process of forwarding non-unicast frames. Make sense? Then if we talk about how switch actually learns the MAC address, then if basically when the data or the frame is received on the switch, then switch would have the details of source MAC address, and it would also have a detail of destination MAC address mentioned into the Ethernet header. Good with you? So the source MAC address would look like something like 02001111 and so on, and destination MAC field would look like 02002222 and so on. Now switch, there is an important thing to notice. The switch basically just trusts the information that is mentioned into the source MAC field. It doesn't trust the information that is mentioned into the destination MAC field, because it doesn't know where that device is connected to. So whenever the frame is coming till this interface, it will just add up the information of, because whenever you're going to start the switch very fresh, then the MAC address table is going to be empty. It will not have any data that is stored into its MAC address table, because the switch has just recently been turned up. So in this scenario, the source MAC address field or the MAC address that is stored into the source MAC field will be learned by the switch, and the same information will be stored into the MAC table. Okay, the MAC table then would look like that 0200:1111 is connected to FA0/1, but still it doesn't know about the 02002222 MAC address, which is the destination for the current transmission that we are having an example of. And such frames about which the destination MAC is unknown to the switch will be called as unknown unicast frames. Okay, and in certain scenario, then what will switch do? Switch basically will forward a copy of that frame out on each interface. Okay, except the interface that the data was received on. So in such scenario, this particular switch will forward a copy to FA0/2, to FA0/3 and to FA0/4, and everybody will be responsible to reply back to the switch that hey there, if there is anyone who is having this MAC address, then please reply back. So the legit user, which is PC2 in our case, will reply back to the switch from port number 0/2. So it will use the source MAC address as the one that it has and the port number that it is connected with. So then the switch will get a reply, and the source MAC address will exactly be the destination MAC address of our original transaction, which is 02002222. Makes sense? And then the switch, as the information is stored into the source MAC field of the Ethernet header, the switch will trust that information and then will make an entry into MAC address table that 02002222 followed by another 2222 is connected to FA0/2. Okay, and this process is basically called flooding unknown unicast frame. So switch does the job of flooding when it comes to the thing. Okay, and that's exactly how switch learns the MAC address. Okay, by flooding, by doing the flooding of the unknown unicast frames. So that's exactly how switching logic works. And then there is another thing that switch uses a method called spanning tree protocol in order to avoid loops by blocking unnecessary ports if there is any scenario that loops can happen in the network. But we will be talking about that later in this video series. So you can focus on such things, that how actually switch, if you talk about the summary, then how actually switch does the job of unicast, multicast and broadcast. Then switch's primary goal is to decide when and where to forward the traffic, and even if it needs to forward the traffic or not. If the MAC address is known in the MAC address table, then it will forward the traffic directly based on the details furnished in the MAC table. Otherwise, it will just do the job of flooding and then will learn the MAC address first and then forward the data onto the designated interface, okay, that it needs to be forwarded. And then it can also drop the data if no MAC addresses are learned about the destination MAC. Okay, so it can drop the frame as well, which is also called as filtering the frame. So that's exactly how switching works at a very basic level. Okay, and in the next video I'll be demonstrating you that how this MAC address is learned. Okay, we'll actually be looking and forwarding the traffic based on the same topology that we have over here. So I hope you enjoyed the content of this particular video, and I'd like to thank you for viewing.